Oh, quite a lot of people. Great. So I guess this talk more caters to you guys as compared to people who are into breaking stuff. But the people who are breaking stuff, give yourself 5 years and you'll be in trouble learning how to manage all that. So, in the 1990s, we saw a lot of networks and all the network security hacks. But with the Web 2.0 and everything else, you pretty much see applications. And now with everything moving towards the cloud, the spread is way too high. And we don't know how much everything else is going to be on the web. And with this web, of course, there's a lot of personal information. My social security is already online, and everybody at Foundstone knows about it. And with also there are a lot of compliances now. PCI is a big thing. Before this, Rahul spoke about credit cards and how to store credit cards. So definitely PCI is coming in. There's other laws like Sarbanes-Oxley and everything else. Besides, there are also the corporate website. So if your website is broken in, say Goldman Sachs, if their website is broken in, next day the stock will go down 20%. And I'm sure none of the Wall Street guys want their stocks to go down. So it's kind of a lot of things at stake for everybody. So we have come up with this approach to deal with applications in general. So what we start doing is we start profiling the applications. Profiling is trying to gather information about the application. Then we take a theoretical approach towards it. Then we start managing the vulnerabilities. And then the actual execution, getting on job and getting the whole thing done. So what's profiling? How many applications does your company have? Yes. Every day you release a dozen, you say? Okay, so in total, how many do you have now? N number of applications?
Nobody knows.
They keep growing every day. So you need to make a database for it. It's as simple as that. You need to catch every developer in your company and get their application on your database. You need to start tracking all your applications. And then once you have all the applications in your database, you need to start classifying them. Like McAfee, our big brother, they have thousands of applications, and they can't keep chasing every application and making them secure. They need to decide, okay, these are the products or these are the applications we are going to protect. And these are the ones we could still let go or will have less risk. So you start taking into account what risk is associated with your application. But how are you going to do that? So there are different things. We have come up with an approach here which kind of decides whether your application is high risk, medium risk, or low risk. And based on data classification, the compliance the application has to meet, the exposure of the application, the reputation, and the availability. So what it means here is, say if your application deals with policies, policy data which can, which is very critical for your company, then you could give it 100 points. And if the application deals with financial data, trading data, then you go to 75 points. Some other sensitive data, you go to 50 points. And something that is public information could be available to all, but Pat here is a big social engineering guy. He could use that public information about you and do a lot of other tricks. So you definitely have to keep that in mind too.
I don't know what you're talking about.
Yeah. Sorry about that. And so with every compliance, so whatever compliance, every compliance your application has to meet, give it a 25 points. We go to the exposure. If your application is on the internet or the extranet, you give it 175 points. If it's an internal application, still, your application is vulnerable to insider threats. So give it a 50 point. Many times you have to do business with other companies, but you do not have control over their applications. So you may, though, be associated with it, but you have to kind of let them control their security. The reputation and visibility. So if the application is very critical to you, say it's your web page, www.xyz.com, make sure, if that goes down, your reputation is at stake. So give it 100 point. Something which is medium will have 75, and something which nobody cares about is 25 points. The availability and the downtime. So since I work out of New York office, I see a lot of these trading applications, and all my friends who are developers, they talk, you know what, my application went down, and Morgan is going to lose $20 million, or Goldman is going to lose $100,000. So that's a lot of money, and you have to categorize how much damage your application can take, and based on that, you have to categorize and give different points. And once you have the points, you have to start doing a total math. And something, what comes up about 300 is a high-risk application. Something which is medium is between 250 and 300. And something which is low is below 250. Say consider an application which deals with sensitive data. So we, as discussed before, we give it a 50 point. And it has to meet compliance of Sarbanes-Oxley and PCI. That makes it 25 and 25. And the reputation of that application is high, and you can't afford any downtime in it. So that brings a total of 400, which makes it a high-risk application. So then we move on to the approach for the application, and how you're going to approach this whole process. So you have to come up with a revisit process. When are you going to, if you're going to see this application today, you're going to pen test it, when are you going to come back and look at it again? Then we come at the testing methodology, what approach to testing, and the testing tools. I'll go in detail in the next slide as we go on. So every high-risk application should be seen at least once in 6 months. This kind of makes sure that things are moving on, your high-risk applications are very secure. Every medium-risk application can be visited once in a year, and every low-risk application once in 2 years. The testing methodology. So what you need to do is, any questions? Okay, sorry. What you need to do is configuration, authentication, authorization, user and session management, data validation, error handling, data protection, logging. So, but what are you going to do in configuration? You need to check if your SSL is strong. Is it using weak ciphers? Is it using the old SSL2, which is vulnerable to man-in-the-middle attack? Does your code have sensitive information? A lot of times we see username passwords, we see database strings, which can lead to complete compromise of your application. Is the SSL certificate valid? And then based on that, we have a criticality for every impact. Not necessarily you could follow the exact same thing, but this is just a guideline for you to follow. Authentication. Is the application using single sign-on authentication? What protocol is it using? How secure the protocol is? Does the application have lockout? How many attempts does it take to have an account lockout? Is the account lockout being tracked on the server? The complexity of the password, and the error messages displayed are generic. The authorization. So different applications have different user roles, and so we need to make sure as user A cannot see user B's data. And also no admin functionality should be online. So a lot of times we see that the moment we see an application, and if we do abc.com/admin, and we can see the admin portal, which kind of means the attack surface increases, someone can get into admin data, and then therefore can leave and compromise the whole application. So make sure most of your applications, or almost all your applications, do not have admin interfaces facing externally on the internet. Make sure that everything is on the intranet. User and session management. So, as HTTP was a stateless protocol and all that, so cookies came into the picture. So you need to make sure all your cookies are, have 128-bit length. They are resetted after authentication. They do not contain any sensitive information. We see all this all the time where cookies have passwords, credit card information, or something which leads to credit card information. The application timeout should be 30 minutes. So data validation, this is pretty much very important. Most of the attacks, and thanks to LulzSec, Anonymous, and everybody else who got going this year, most of the attacks here are through data validation. Make sure every input, every field in your application is validated on the server. Client-side checks do not work. Anybody can bypass them. Encode all data, use parameterized queries. Another thing is command injection. Though lately we at Foundstone haven't seen a lot of it, but sometimes, especially back like 3-4 years back, people will take data input and pass it on to the operating system, and you could execute commands directly. Error handling. So this is to do with how you handle error messages. So yesterday I was on the flight and the internet there, that leads to all sort of error messages. So you need to make sure your application does not lead to any error messages. What error messages can do, they can reveal more sensitive information about what technology you're using, what database are you using, and based on that, people can start attacking your application. Data protection is to do with, are you setting your cache parameters correctly? Is there any sensitive information in the GET? If you have any sensitive information in the GET request, it is getting not only cached on your browser, but also getting cached on the server logs. So make sure you don't have any sensitive information in the GET. Use post for every information. Data encrypted in the database. I think Rahul covered a lot about encryption in database. So I guess I'll move on to the next slide. So logging and auditing. So this is for you as a company to track down what's happening internally. Make sure you log every small thing. When the user logged in, when the user logged out, how many attempts did it take for him to get in, the IP addresses, the IP range where the user logs in from. The more information you have, the better it is for you if something goes bad. So try to log in a lot of details. Some of the examples here are here. So the testing approach, it's always a fight, and everything is pretty much clear. It's always white box versus black box. So what testing approach should you take as a company? So if you go the white box approach, what will happen? You'll know the exact location of the finding. But what happens is you will not know anything about the whole architecture or the whole structure or the findings for the operating systems. So what you could only know something about the application, but your application sits on your operating system and your web server, and if both of them are vulnerable, then your application being secure does not help. So with the black box, you will not know the exact location. Probably you get an idea about what is happening. But black box is less time consuming. Less time consuming also means a lot of less money. Say for a code review for an application, Foundstone will take 3 weeks to do it. But as a black box test, we only take a week to finish that same application. So it's more time consuming to do a white box test as compared to doing a black box test. And of course, the more time you spend on tests, that means more money. So we need to strike a good balance between doing a black box and a white box approach, which is kind of called the gray box approach. So what typically happens is a lot of our customers give their code base. They also put up the application on the server. And we start looking at the code. We also start doing a little bit of black box testing and take a comprehensive approach where both the code as well as their application is analyzed in a black box manner, or a gray box manner, I should say. So some of the testing tools developed around it, and something what has happened is the big guys have come in. IBM has taken up a company, HP is there, and Hailstorm's kind of lost behind in the battle, especially with the amount of money HP and IBM have poured in from 2007. But these are the tools which most companies use for their applications. So moving on to vulnerability management. So in vulnerability management, now we're going to cover the knowledge base, the training required to have that knowledge, the classification of the vulnerabilities, the time frame associated with it, and then the remediation planning. So the knowledge base, so there are hundreds of attacks. What attacks are you going to cover as a company? And you have to start putting all the attacks and the different vectors to it in the database. So like this week we have a client. We found a cross-site scripting, and we, through a simple script, alert one script. And doing the retest, that script does not work. And we put a single code alert one, and it works. But according to them, that is out of scope. We only told them that, hey, we could inject a script, alert tag, script tag, and alert one, and now with that, just changing the script is out of scope for them because they do not understand that the vulnerability as a whole classifier is running a script and not a particular text. So new class of vulnerabilities are being identified every day. You need to have regular update of knowledge base. Training. So training is the most important thing. Everybody here is here because they want to learn something new about security or something what's happening in the security space. As security professionals, training is the key. You need to read blogs. You need to update yourself with what's happening around and take that training into your knowledge base and start building a process internally. The vulnerability classification. If you find a cross-site scripting, what are you going to rate it as? What does your company rate a cross-site scripting as?
Medium.
Medium. Pat, you. What do we rate it as?
It depends on the context, right? I mean, we've seen cross-site scripting attacks on login pages, which are hugely impactful. You can steal people's credits. Post-authentication is probably not going to rate as high.
Yeah, so we need to come up with an approach to rate your findings, to rate a cross-site scripting or to rate any finding what we have. So what we do is the impact. What could be the impact? And what is the likelihood of that vulnerability being exploited? And so if it's a high impact, high likelihood vulnerability with a high impact, then we rate it as high. And you have to come up with an approach. So something which the industry has, this is what people were doing before, but now with the CVSS calculator, everything, most of our clients are asking for this rating. So CVSS is, this is CVSS 2 calculator. So what it asks for are way many different things. So the access vector. How can you access the application? Whether it's on the same network, whether the vulnerability is on the local box or on the adjacent network. The access complexity. What knowledge do you need to have to access the vulnerability? Is it very complex? You need to write your own shell code, or can you use just basic math to do it, or some basic tweaking around? What's going to be impacted? The authentication. Authentication? I think there's something wrong here. One second. Oh, sorry. It's right. Authentication. So what type of authentication does it use? How many authentication does it have? Is it a single-factor authentication or a multi-factor authentication? And where the vulnerability exists, is it before authentication or is it after authentication? That's very important. The confidentiality impact, the integrity impact of the availability of the application. The requirement for CIA, if your application, as we discussed before, is low rated, then your requirement for CIA may also be low, so you may not have to worry too much about that. So the CVSS calculator takes all this into picture before giving you a score. And what it does, it gives you a number between 0 and 10. And what 0 to 4 is a low, a 4 to 7 is a medium, something above 7 to 10 is a high risk. So once you have all this information, you have created policies about when you're going to test the application and what you have this knowledge base, and if you find this vulnerability is going to be a high or a medium, then you have to come up with a process about how you're going to test it. So you have to come up with a kickoff call. In the kickoff call, you need to set expectations about what you're going to do. You have to explain the application people that this is what you're trying to achieve from the call. You don't have to scare them away. security is a process about helping everybody to be secure and not saying, oh, you know what, you are vulnerable. So we need to scope out purpose of the very well, where we are trying to help the application team and not drive them crazy. We also need to have working credentials, user guide of the application, and we also make sure that we are testing test environment. Many times what happens is developers always fail to meet deadlines, and then they insist on testing on production environments. Testing on production environment could lead to a lot of garbage in the database. Testing schedule. So once we have a schedule, we fix up a schedule to test an application with the application team, then we need to send them regular updates about what is happening with the test. Just after weeks of testing, just giving them, a 20-page report will not help. You need to send them what you're doing every day and how's the progress looking. You need to keep them in the loop of what is happening. And then with every day, not necessarily every day, but every week, you need to sit with them and explain them what you found, how you found, and what it means to the organization and how it will be exploited. Yeah. Yes. So suppose if the application has 3 different user types, then you should definitely ask for 3 users, 3 different types of credentials mapping to all the 3 user labels. And with every user label, you should ask for 2 credentials. So you can cross-check it. Suppose you logged in, and we both have the same credential, same user access. You need to check whether I can see your data or you can see my data. Does that answer your question?
For lateral escalation, also if you lock one out, right?
Yeah, if you lock one out, then you could block the testing for some time. So you need to be, ahead of time, kind of a deal. And please make sure to disable all accounts after the test. Now, we can have accounts running for years on the same application. So testing time frame, you could be testing forever one application and keep finding stuff, but you need to move on because, as everybody said, there are n number of applications in the company, and you can't sit on one application forever. So you need to come up with a time frame for testing an application. So your application is a standard 25 to 50 dynamic pages application. So this could be a time frame for your application. Configuration management could take 4 hours, authentication 4 hours, authorization 8 hours. Data validation is important, more focus on that, 13 hours. And logging and reporting. So reporting, all consultants hate reporting. We just want to dish it out to the client and give it to the client and tell them, figure out your shit. But reporting is the most important thing in the security industry. The more focus we put on reports, the lesser time it takes for the application group to fix vulnerabilities. So it's very important to have good structured reports explaining each vulnerability in detail and where they exactly exist. Coordination explanation, as I said before, you need to sit with the team and explain them vulnerabilities in detail.
Narainder, I think that's really super important, right? So too often the security guys in an organization or the consultants that are brought in to test an application, they're seen as the guys that are threatening, whoever's responsible for that application. They're seen as threats, right? Like, this guy is telling me that my app is broken. I might lose my job. So, like you said, the communication piece is key. You need to make people feel like you're there to help, right?
Yeah. So
Like you're an adversary.
yeah. So you need to make sure you are on their side, and you have to communicate it's our problem and not your problem. You need to work with them. So we got a remediation plan. So you need to come up also with a plan about how you're going to remediate, and you have to come up with a time frame of remediation. You can't have vulnerabilities lying around. Now that you know something exists, you better fix it. So a high-risk vulnerability should be fixed as soon as possible. Medium, within 30 days. You could set timelines for application groups, and something which you could go back and do a retest on what you found. So risk acceptance, this is something very important. So a lot of our big clients have something called risk acceptance, where you have to accept the risk. The reason you accept the risk is it's too expensive to fix it. So and there has to be a definite procedure. You cannot accept a risk for a SQL injection on your login page and someone can log in. So there has to be a definite procedure about accepting risk, where you have a process where, okay, it meets this criteria, the rating is medium or low, and it requires XYZ permutations. So we're going to accept the risk this time, but when the application comes around next time for a test, you make sure you fix it. So you have to come up with proper, appropriate guidelines to accept the risk. Now something important, you have this whole policy or the rules and the guidelines set up, but now is the time to get on the ground and do the job. So there are different approaches to it. Different companies take different things. They do a mix of it. The internal team, the external vendors, and how it's actually implemented on the ground. So with the internal team, what do you need to have an internal team? You need to have a bunch of smart dudes who are sitting there. And of course, with they being there, coming to office, you need to provide them space. You also need to provide the infrastructure to go and do that testing, to perform the test. You need to buy them licenses for different software which they need to do the pen test or whatever reviews they are doing. You need to help them develop in-house tools. Besides covering all this, you also need to send them to regular trainings so they are updated with the market. They need to know what's the new attack, how people are doing that attack, and what not. So the external team, there are thousands of vendors out there. What vendor are you going to select? So you need to make sure what are your requirements, what's your budget with it, and what vendors fit into it. And based on that, you need to come up with a vendor. Then the reports. So every vendor or every company has their own format of the report. But as a company, suppose if I'm looking out for a vendor, I need a reporting structure which will fit me and something which I could use to extract information and use it for my application team. So there has to be a protocol where even if I'm hiring a company, they come up with a report which helps me so that I can write scripts around it to extract the information I need. There is a little time where I can always end up reading a 100-page report. So I need a way where I can run scripts and extract the more important information, like say we found 4 highs, 5 mediums, or 6 low vulnerabilities. So I need something to work. And besides this, even if you have you decide to go completely with the external vendors, you still need to have an internal team. This internal team at least will have to coordinate between your application developers and the external vendors. And they will act as an interface. They will set different guidelines, different time frames for the application to be tested. They'll take all the necessary information from the application team, pass it on to the external vendors. So the implementation of it. So, most companies do, at least the big companies have internally an application team, a security team, and they also call in external vendors from time to time, and it's kind of a mixed approach. And the other implementation part is how you're going to convince the C people in your company to get the attacks, to have application security or to have any security for that matter. Are you going to wait for a company to be hacked or your own application to be hacked? So, but now with the whole LulzSec and the anonymous thing happening, it's everything going gaga. All security companies are super busy, super hiring, and everything is good for us. The relationship with developers. So another approach, what happened with the acquisition of the security tools by HP and IBM, they got clubbed into the development tool like Rational. And now the whole approach towards security or the whole focus of security is on the QA guy. Are the QA guys in a position where they can provide that security? Do they actually know about security is the question. So if the balance is moving towards QA people doing your testing or QA people providing you security, it's not going to happen. It's not going to work. We're still not there. Over the period of time, we need to have you have to have training for QA people to understand what it means, what a cross-site scripting means, or what a SQL injection means, and maybe someday they will get to it. But as of now, where it stands, it's very difficult for QA people to be security testers. Anybody with any questions? All right. Yes, thank you so much, everybody.